So I just wanted to take a moment to go over the sort and search assignment that you were given. So first of all, I assigned an array. Everyone was given that. Everyone was also given this code, which simply goes through and prints everything out. Then you were asked to do one sort of search or the other. I did both of them just to show you, and you'll see I also have attached my code. For the insertion sort, remember you need to start with the element at position 1, which is essentially the second thing. And then you cycle through and you compare it to everything to its left. As long as something to the left is out of order, you're going to move that. Okay, so that's what this does. It moves everything that is out of order to its left. Um, then you go one index further to the left, working your way back towards the start of the array until such time as you hit the end of the array or you find something that's in order. Now, once you find the appropriate slot to put it, you're going to have a step like this, which takes the element at index I, which you're originally looking at, and puts it into that slot. Note you want to do a j plus 1 to get the right slot, your index plus 1, because in this step right above it, you subtracted because you keep decrementing. So to kind of get back to the appropriate slot, you do the plus 1 and you put the missing elements in there. Let's look at a selection sort. So I defined a couple of variables there, j, which is my inner loop index, and a min index. And then what I go through a bunch of times, this time starting with element 0 and going through the one less than the last index. What I do for each case is I start with setting my min index. I assume that it's whatever's the first thing, whatever's at position I. Then I go through the rest of the array, so I plus 1 onward. And if I find an element that's less than it, I set that now to my min index. Okay, so that tells me the position of where my minimum element is. And once I've done that, I've now identified where my minimum element is. Then I do a swap. Okay, so standard swap, to use a temp variable. I swap the current I position that I'm cycling through. Remember, I is defined in the loop. And I swap whatever elements at I with the one at the min index. So that's it for the selection sort. Then you are given another print. Okay, it just runs through and prints it again. For the last one, I asked you to do a binary search. So you might have gone back to Code HS to take a look at that. That's probably a good strategy. The one thing I asked you to do additionally here was to go through and keep track of the count. Okay, so how many times does it have to look before it gets something? So you start by setting count to 0. You have this, you start with your low at the lowest possible, the high at the highest possible. The index -1, that's sort of a default. What I'm going to do is put the index of whatever index I find my key at. In this case, my key was 13. You calculate the mid. Remember, you always start in the middle. Now that we have a sorted one, we know that in the middle is going to be, the midpoint of our data. And I look there and then I either go up or down. So that's basically what this is doing. But one thing I did want to point out is that once you find your current, and a couple of you had some issues with this, I saw some infinite loops. So people are getting stuck inside this while loop. You do need a way to get out of it. Now, typically, you might write this in a method. If you write it in a method, you can just do, once you found the index, you could return the index, is usually a good way to do it. But in this case, this was all part of the same method. So return statement is not really going to help us here. So we're going to use a break. The break will get us out of the while loop. And I set the index to mid, which is the current element that I'm checking. I use the break to get myself out. And then once I get to the bottom, I can print that out. I just printed out the index as well as printing out the number of steps. That was not required, but I just thought that would be useful to show you what's going on. So it finds it at index 8, which means it's in the 9th position overall, and it counts the number of steps as we showed. Remember the count, again, it's going to be equivalent to however many times I go through this while loop. Each time you go through the while loop, you're checking something else. All right, that's it. Hopefully that helps. If you have any more questions after watching this, please let me know. Thank you.